So my name is Myles, and as Poch mentioned, I work at a small disruptive cloud startup firm called IBM. My full-time job is contributing to the Node.js platform. We're going to talk a little bit today about what I do there. But I do want to mention these, are my opinions and not necessarily that of my employer. So versions, how do they work? So versions are a lot like magnets, and stick with me on this, that versions are a lot like magnets, mostly in the sense that people are pretty confused about how they work. We just kind of we're like, it works. It sticks to something, versions come out. We don't need to know. Hashtag real talk, this stuff is complicated. This stuff is not super grokkable right away. If y'all have heard that term grok before, I love it. Just like the ability to internalize and understand something. But so the great thing about computers is you actually don't need to understand everything. And when you try to understand things, that's like when it gets complicated. You don't need to understand everything to contribute in a meaningful way. You just need to know enough to be dangerous. Let's break this down and start from really small pieces and build it up and see how these complicated systems start coming together. And we'll start with semantic versioning. So I'm going to go out on a limb and assume that many of the people in the audience here have seen a version number before. And versions are usually made up of 3 digits. We have a first digit, which is known as the major, the second digit, which is known as the minor, and the third digit, which is known as the patch. I'm thinking about trying to push for a 4th digit, which will be known as the marketing release digit, but no one's been into that yet. But so what's a patch? And a patch is any change to a system that fixes a bug or updates a test, any change that does not add new behavior and does not change old behavior. And this is really important. The idea with a patch is that someone should be able to take a patch updated version of software if they're consuming your software and update it, and their code base should just get better. They shouldn't have to make any changes, and they shouldn't have to worry about stability. What's a minor? And so a minor is any time there is a new feature added to software. You do a minor bump. In Node, for example, if we add a new way to do crypto, that will come in a minor. What a minor signifies and is important, it's like, hey, the functionality of your code is not going to change, but there's some new stuff, and that new stuff may not be as stable as you may want for production. So you generally can update to a minor release and still, again, not worry about your production code having any problems. But at the same time, you may not want to jump on the bandwagon right away of using these new features. So what's a major? A major is any breaking change. Any change that changes fundamentally how the code works. And we'll dig in a little bit more later in the talk to describe what major changes are a little bit more. So in Node.js, we have a number of different release streams. We have current, which is, as of, I think, last week, version 6.5.0, which was super cool because we upgraded V8 in version 6. And I'll, again, talk more about that afterwards and why that's so cool. The current active LTS is version 4.5.0. And then we have maintenance LTSs of version 10, which is 10.4.6, and version 0.12, which is 12.1.5. Everyone in the audience, look at me and promise me that you will stop using them. 10 and 12 are end of life very soon. As of next month, in October, we will stop updating version 0.10. I know we've loved having it for as long as we have, but it's done. And version 12 is going to be done in December. And the reason for this isn't just because we don't like working on them, which also might be the case, but the version of OpenSSL that they rely on is end of life for security updates. And if any of you have been following security in OpenSSL, you know that there are vulnerabilities found all the time, and it's an extremely dangerous attack vector on your servers. So it just will no longer be safe to be running those versions of Node in production after October and December. So I really urge you to start trying to push to version 4, and we have a lot of resources available to help you do that if you're having problems. So let's talk about what happened to version 1 through 3, because I mentioned there was 0.10, I mentioned there was 0.12, and then all of a sudden it went to 4. And also, what's the deal with 0.12, because that one's kind of weird too. So when Node started, it was done with an alternating release scheme. So every even release was a stable release, and every odd release was unstable. So the way that worked is I started using Node in 0.6. 0.6 was the stable branch. If you were on 0.6, you could trust that it would work. 0.7 was the unstable branch, where things were constantly being updated and played with and changed. When it was ready for a major bump, which, by the way, in Semver, if you don't have a 1 in the first digit, everything shifts over, and your minors are majors, and your patches are minors, and then you have no patches. And this is a reason why it's a good idea to always start a project at 1.0, because you will never get to 1.0 otherwise, and you're losing like an entire, it's just bad. But so even with stable and odd was unstable. And it started to take a really long time to bump from 0.10 to 0.12. And by a long time, I'm talking like more than 2 years. And not only did we not know when we were going to move to 0.12, but we also didn't know when we would eventually hit 1, as I was just saying. And so the Node project was moving with this entire missing piece of granularity as far as how we could let people know where we're going. And so in December 2014, a number of contributors from the project forked, and they released the fork as version 1, which it turns out is actually proper semantic versioning. There was a major change, and the major change was it was a new project with new people. Version 0.12 was released February of 2015, right before Node Summit, which was a conference that was held in San Francisco. Version 0.12 did not have a lot of the things that were happening in the I/O branches, but it did have some new INTL features and an upgraded V8. V8 is the JavaScript engine that's embedded in Chrome, and it's also the JavaScript engine that we use in Node. And that was another reason why the fork happened. V8 hadn't been updated in a really long time. When you want those new ES6 language features, those come with V8. So when V8 doesn't get updated, your VM isn't updated, you're stuck on old JavaScript, and that's no fun. So V1 through V3 were all part of the IO.js project, and these were all updated constantly based on semantic versioning. The project moved extremely quickly in a short period of time, moving from V1 to V3. It was not about specific release cadences. It was basically whatever had landed in master, they just did a bump based on what made sense. So in September 2015, Node and IO managed to have a merger, and it was put into a foundation. And when the projects merged, they merged as version 4.0.0. And this was like a huge feat. When the project was forked, a lot of people thought that it may not get past this, that the project may be over. But you can't stop JavaScript. So what you see above me is the Node LTS release schedule. There's a lot of information here, so I'm going to try to walk you through it all. But essentially breaks down how we do our release schema and how things are released. So you'll notice there you can see 0.10 and where it stops in October. You can see 0.12 and where it stops in December. You can see master, which is an unstable branch. We can see version 4. Version 4 was cut in August of 2015, and it was our current release for 6 months. At the end of 6 months in October, it rolled over into LTS. And our LTS, which is short for long-term support, has a 30-month support cycle. It has 18 months of active LTS, which means we're actively backporting as many commits as possible from our active support lines into our LTS support lines. After 18 months of active LTS, it goes into maintenance. And so let's talk a little bit more about that. So current, which you saw on there, is the most active stream. Right now, version 6 is current. Next month, we're going to cut version 7. Version 7 will become current, and version 6 will become LTS. The current release streams are done in an interesting way now. It's somewhat similar to the old way of even and odd. All even release streams will eventually move into LTS. All odd release streams will not. Version 5 was the first odd release stream that we had, so we weren't really sure how long it would keep moving after we bumped to version 6. And it turned out that after about 2 or 3 weeks, the usage of version 5 dropped by like 90%. So in general, if you're using things in production, I would advise you to stay away from any uneven number release streams. unless it has features that you specifically need. I would even generally advise you against using current early in the release stream cycle because things can be unstable. One of the big differences about the current release over the LTS release streams is current will take any Semver minor and Semver patch commits that are sitting on master and add them to the next release. There's no baking, there's no incubation stage. For LTS, active LTS, we take any commit that has landed into master and then been in a release. And once it's been in a release for at least 2 weeks, we can then backport it to LTS. So that's one of the nice things about an active LTS line. You know that every commit that's landing in there has not only gone through our vetting process for getting landed, it's gone through our testing and CI and smoke testing, but it's also gone out in a release and lived in production for a number of weeks before we even bake it in. And it doesn't mean we never break anything, but it does mean that we're a lot better at it. So I had mentioned maintenance LTS, which is a little bit slower than active LTS. Maintenance LTS is the 12 months after active, and the primary purpose of it is to make sure that your systems that are running on LTS are going to have extreme security vulnerabilities and extreme breakages covered. So after the active period, you'll have another year where the LTS branch will have all major security updates and all major bugs patched and updated for you in a way that should not change any of the functionality. Now, sometimes with security fixes, we can't avoid that. So there were some recent security fixes we had to do to our HTTP library that involved what would be arguably a Semver major change. But unfortunately, sometimes for the sake of safety, we can't exactly follow Semver. But for the most part, what is good about this, if you have an app and you're putting it in production, and it's something that you aren't going to need to change or touch too much, you know that you can rely on an LTS branch for 3 years from the time in which it's cut until the time in which it's done. So what about master? Master is this really amazing, beautiful thing that everything just lands on. We land absolutely everything into master, and then we use it as a source of truth for grabbing things to other branches. What happened to stable? So I don't know how many of you have been following our release cycles really closely, but for a little while, we had a release stream called stable. It's now called current. We found that like in the verbal contract between us and the people that use Node, that wasn't exactly fair because stable seems to imply, hey, things aren't going to break. And as I was saying with Semver minor changes, we're not necessarily guaranteed that things that come into a current branch are going to be stable. So we changed the name. So if you hadn't heard about the term stable before, this slide, just ignore it. Take it out of your head. You don't need to remember that. But yeah, so how the heck do we manage all of this? It's a lot of stuff. And magic is mostly, but more accurately, Git magic. Because Git is magic, and it's magic with trees, and that basically makes us elves. But we maintain release branches. So for every release stream, we have a branch .x. So we have 0.10.x, 0.12x, 4x, 5x, 6x. Each of these branches are at the head of the last release in which we've done. When we're ready to make a new current release, we branch off of that .x, and we cherry pick commits from master onto it. We're actually in the process of changing this release process to more match our LTS release process so that things can be more the same between different stuff and also to avoid conflicts. And if you're interested in hearing more about that, come and grab me afterwards and I'll tell you more. For LTS and soon for current as well, we maintain staging branches. So as changes are audited and are signed off on for LTS, they get cherry picked onto the staging branch. Then when we're ready for a release, and as I said before, those are changes that live for at least a week. And when they're ready for release, we do something like this. So we've got staging here, and I can check out v4.x. Can everyone read that? Scream enhance if you need it bigger. All right, we're good. OK. How's that? Is that enhanced? So we can check out a new branch here called v4.5.1 proposal. So we have a new proposal branch, and we can use a tool, and I'll talk more about it after, called branch diff. And we can see, hey, what's the difference between this branch and the staging branch? And we see all these commits that are different. And so we can go and we can say, we want the format of SHA, so we just want the SHA. We want reverse, and we can pipe it to xargs git cherry pick, and this is some fun piping stuff. And we see all this stuff go through. And now we've just made a release branch for v4.5.1 using all the commits that have been staged in our staging. And so the reason why these staging branches are really great is now on the day that we're ready to do a release or the day before a release when we want to start testing it, we're not going to be blocked by silly things like merge conflicts. The staging branch is where we can go and take commits and make sure that they're not going to cause a problem. I had talked about like how we actually go about landing commits. So I'm going to show you a little bit about how that process works. So here's Node. And again, if things are too small, just scream out enhance. That's the only time when I'm going to, oh, the internet's down. Okay, so let's pretend. So what I would do is I would go to an issue and I would go and grab the commit. Are we still down? Okay, so I'll come back to this demo in a little bit if the internet comes back. But I was going to patch Node live for you, and maybe we can do that in a little bit. But so when we're ready for an LTS release, as I was saying, we branch off at 4.x and we cherry pick the commits from staging. So how do we know which commits to cherry pick? And so this is what I was talking about with that tool. We use GitHub labels, and that's what the tool runs off of. All of our pull requests have labels. Some of them are semver major, some of them are semver minor. If they're commits that we think need to be backported to specific streams, we'll add an LTS watch label to it. And if there are commits that definitely shouldn't be on certain streams, we'll add don't land. So one would be LTS watch v4.x, one would be don't land v4.x. And then we have a bunch of tools. So the tool that you saw me using was a tool called branch diff. Branch diff is a really unique way of handling diffs. With Git, when you do a git diff between two branches, it's comparing the trees. So one git tree and another git tree, it will see if they're the same, and it will tell you what the differences are between the trees. But what we're actually interested in more is atomic units of change, but not what happened in the atomic unit of change. We want to see every single commit, and we want to compare their messages and their metadata to see if they exist on two streams. Because the commit on master can actually end up being very different than the commit on version 6, which can also end up being very different than the commit on version 4. So we want to make sure that we have all the same atomic units of change, but not necessarily the exact same git trees. So branch diff is able to use a combination of metadata comparison as well as labels from GitHub to let us know which commits are missing. So when you saw me do branch diff here, and maybe doing that actually took down the internet, it was able to give us a list of, hey, here are all the commits that aren't on this stream. And we can use that to figure out what we need to land. So when I'm ready to do a new release of version 4, I can go and do a branch diff between staging and master and just have a big list of all the commits that haven't been audited yet. And I can go through those and make sure that we get everything we need. We have another tool called changelog maker. That's really great when we want to go and make our change logs. That can go through and take the diffs, it puts it in Markdown, it can organize it for you. And every time we make a changelog in Node, we use the changelog maker. Both of these are tools you can install with NPM, and both of these are tools that you can use on your own projects if you're interested in having that in your workflow. We have a number of different scripts as well that we use for building all the assets and deploying. Oh, this is a good one. So what's a breaking change? This is the biggest thing. A breaking change is any time there's a change in behavior. And that seems really obvious, like if you switch two variables in a function. That's a pretty obvious breaking change. But sometimes breaking changes can be a lot more subtle than that. And you have to create a lot of infrastructure in order to test why things are breaking. So how do we in the Node project avoid breaking changes? One way is CI. We have a pretty extensive testing suite, and we have CI running for all of the different architectures that we release to. So we test on Debian, we test on Ubuntu, we test on Fedora, BSD, Solaris, Windows, Mac, ARM, multiple flavors of ARM. So we have all of these different operating systems, architectures that we're building and testing on every time we want to make a change. But that doesn't catch everything. We also do something called smoke testing. So there's this utility that I created called canary in the gold mine. Well, it was actually created by James Snell, my mentor at IBM, but I carried through a lot of the work on the project. And canary in the gold mine will go and grab an NPM module. It will NPM install it and then run NPM test and then give you the output. And so we have a list of 70 of the top used modules in the ecosystem, and we can run sitgem on that every time we want to make big changes or periodically against our branches and see if we're breaking things in the ecosystem. And the nice thing about this is everyone's code that's using your code that has unit tests are essentially writing integration tests for you, so you may as well just run them automated. In February, we found these two interesting breakages that I want to share with you. One in Jade, which many of you may know is a templating language that's really awesome, and the other in body parser. And body parser is the embedded body parser in Express. Express is used a lot, body parser is used a lot. We don't want to break that. So it turned out Jade had to change their name to Pug, and they didn't update their package JSON, so that broke our algorithm for grabbing tarballs. So we sent a pull request, and that was pretty quick. But how body parser broke was pretty subtle. So we had some extra logic added into query string .parse. It's using string.split inside to break apart all the query strings. And we were doing a comparison between the length of the array and the max length that was passed, and just shortening the array. That was the way we did it originally, and that creates a lot of garbage. So someone submitted a pull request that went through and just passed the argument of max length to the call to split. And you know, like, that's a pretty great idea. It speeds up a whole bunch of stuff and creates less garbage. And that's the change. You can't really see it. But so something really weird happened with infinity. So before the change, if you required query string.parse, and you parsed the string, and you gave max keys length of infinity, you would get the expected length. After the change, it would always give back 0. This is completely unexpected. It turns out that query string.parse, the second argument, is expected to be an integer. When you pass infinity, infinity gets cast as an integer. And it turns out, by the spec, infinity as an integer is 0, which mathematically is more correct, but obviously it didn't work out. So smoke testing saved the day. We were able to go and there was a single unit test in body parser that tested infinity as an option there. It was an edge case we didn't test in core, so we missed that, we broke it. But none of you have to know about that, because we found out about this before a release. We patched it and fixed it before a release, and smoke testing saved the day. So as I said, the change wasn't on master yet. So there's all sorts of weird things that Canary in the Gold Mine has found. Come and grab me if you want to find out more. I have a diary that I've been keeping, and actually on Thursday, I'll be giving a talk in Amsterdam at Node Interactive all about this. And if you're not going to be there, the video will eventually be online. And just keep bugging me on Twitter, and I'll let you know when it's available. So to wrap up, which version should you use? At the moment, v4.x, but I mean version 6 going into LTS next month, so that's not a bad choice either. But why? Longest support cycle, closest to master of LTS releases currently, and the least likely to break your app in production. Do you have to? No. I mean, like, do whatever you want. That's totally cool. We need people running on the bleeding edge too. Just, you know, if you're gonna run v6, it comes with v8 5.1, as I was mentioning, which is like 98% of ES6 features. It's gonna be LTS in about a month. Totally makes sense to run on that. Should you run v7 in production when we release it next month? I would say probably not, but also, like, I mean, cool if you want to and you're ready for firefights. So as I was saying, next month v6 will be LTS. So that's pretty awesome. We updated the v8 in it. Grab me if you want to hear more about that. And be prepared for breakages if you're an early adopter is kind of the only warning that I can give you. Thank you very much. I leave you with the best GIF on the internet.